Okay. So we're going to go through the results, and then down below your table, you're going to answer some questions. And they're really easy to start with, and they get a little bit more difficult as we go. So within these boxes here, when you have written down,
Correct.
Oh, now that doofus. Where the hell were you? Yeah.
hey, guys, up here. Thank you. Okay, so as we look at the reactions, you should have a reaction here and here. Is that the case?
Yes.
Okay, they reacted quite a bit.
Yeah. And the next one.
So within here, there should be no reaction and probably no reaction.
That one bubbled up for me.
Sometimes there'll be little bubbles around there. I'm not sure what causes that, but a lot of times you look for changing color to see if a reaction happens. Unless it's really bubbling a lot, then we just say no reaction.
Okay.
Okay?
All racer.
Right. In here we should have no reaction. Is that right? And then this is a tough one. This one can go either way. If you shined it up good enough, I think it should react. But you should have a reaction here. It's a really tough one to see sometimes. So I can see where when you do that one, it doesn't look like it's much of a reaction.
Couldn't it get rid of the color?
It might have dulled it a little bit.
No, ours was like looked like it was silver.
Is that right? Yeah, that's okay because you got a change in color. And then in these three, they were definite reactions, all three, right?
Dissolved, corroded, and corroded.
Okay.
Turned white.
So anytime you see a change in color or something real definite, then it would be a reaction. Okay, so this is the first time that we're going to go through actual chemical reactions and show them. Okay? So I'm going to have you answer 2 questions for me, actually 4 questions for me. You can just give one-word answers with those. So answer those 4 questions. You don't have to write them out. Just write 1, 2, 3, 4 down below your table and answer those 4 based upon your data table we just went through. Okay? Take a minute to do that. So, Destiny, what do you have for the most active metal? Mg. So Mg is the most active. If it was out in the environment, it's the one that most easily corrodes. Okay? Marcus, what'd you get for what's the least active?
I put copper.
Yep. So copper was the least active. It didn't react with hardly any of the solutions except for silver, right? That's the only one it was reactive with. Okay, questions you guys have with those 2. And then zinc's in between. All right? So the question is, which solution? Now this is asking something a little different in how you interpret it. So which solution was most active? Hunter? What'd you have?
AgNO3.
Okay, so AgNO3 would be the answer. And then what was the least active solution? MgNO3? Okay, so good job on that if you answered those all. So all you're doing is you're taking this evidence right here. And you're going, okay, I'm going to look at it, and when I look across, I can see which one's more active, and Mg is most active. And when I go down, I look at which solution had the most reactions in it, and I could see silver nitrate had the most reactions, and Mg had no reactions whatsoever. Okay? Any questions you guys have with that? Okay, now we're going to take it a step further, okay? First thing I'm going to do is I'm going to write a reaction out. Okay, so I'm going to have somebody, Caleb, give me the metal and the solution that you had a reaction in the well for.
Let's go with Mg and CuNO3.
Okay? All right? So we're going to do a second one here. I want you to write that out under number 4. Well, let's make this 5. So number 5.
Like question 5?
Yeah.
Okay.
Xavier, give me one that you had no reaction. 2 wells where you had no reaction.
Zinc with the MgNO3.
That would be number 6.
Is this number 6?
No, we'll just have this all under 5.
Oh, this will just be. You just said it
This will just like an A and B under 5. You don't have to list them A and B, you just have them both. Okay, so we know that this one reacted, and when it reacts, we form products on this side. Okay? This one didn't react, so this one has no products. Okay? Drake, you get your head up, please. I know, it's tough.
Yeah, it is.
I know. So write these 2 out.
Already did.
All right, so there's nothing happening here. Nothing. Between those 2. But between these 2, we have something rearranging. Okay? Something's happening where these have to rearrange. Okay? I'm going to go ahead and write some values above these, and I'll explain what they are. So if you got an element by itself, it's considered a 0 charge. It has the same number of electrons as protons. You guys remember when we did isotopes and had the chart, and electrons and protons equal one another? We said that that element had no charge. 0 charge. And then we had some that we had more electrons or more protons than something else, and they had plus and minus charges. Okay? And we've been going through, make this a 2, plus 2 instead of a plus 1. We've been going through and putting these together and trying to figure out how many we needed of each. So that's what we did the last 2 days of last week. We tried to put these together so that the charges balance out. So that's kind of the first step of the process of learning how compounds go together. Okay? I want somebody to maybe make a prediction of maybe what could go in one of these 2 lines. So if they react, give me what you think would maybe go in one of those 2 lines.
Mg.
Okay? Now, if so on the product side, it has to be different.
Oh, so. Okay.
So if I write Mg here, and actually, you got to start somewhere. So if I write Mg there and I look at left side and right side, they have to be different on both sides. I have to have a different product. That would be the same product, so we would say, nah, it probably wouldn't work because they're the same. So, somebody else. Yep.
Cu.
Okay. Could we maybe put Cu there and it would be something different than on the left side?
Yeah.
Okay, we could. All right? And then what's left over, we can put that together. So what's left over is the Mg and the NO3. So Mg and then NO3. And then this is a plus 2, this is a minus 1, so we have to have 2 of them. Okay? So that is the actual products that you would get during that reaction. Okay? These are called single displacement. What happens is Mg is more active. Didn't we say Mg was the most active element?
Yeah.
Okay, Mg is the most active of the ones that we did. It's going to kick out the other element that is more active than, copper. And then copper's going to go off by itself. And then what we're left with is Mg and NO3 go together.
Yep.
Okay. Now, this one here, this one tries to replace magnesium, but it doesn't let it. Magnesium is more active. Okay? Didn't we say magnesium is the most active? Nothing replaces magnesium. Look at your wells with magnesium nitrate going down. There was no reaction there. Okay? So in this, here, there was no reaction. Copper couldn't kick magnesium out. Zinc couldn't kick magnesium out. Okay? Now if you look at silver, everything kicks silver out. Copper kicks it out, magnesium kicks it out, zinc kicks it out. Okay? Questions you have? Okay? I want you to see, since we did one together, under number 5, I'd like you to put a third one, and let's have you do copper and AgNO3 combination. So I'll write it out. Okay? So we're going to go copper solid plus AgNO3, and I want you to make a prediction of what the other side looks like. And I'll give you the charges. So this is 0, plus 1, minus 1. So go ahead and write in what you think that products are going to be. So you guys make a prediction. Now you've only seen one of these. Zn plus CuNO3 2. Do that one and see what you come up with. Try to make the prediction. I suppose if you need to go. You know.
Everybody's gonna drink the food.
Yes, Bryce, you can go get a drink now.
I should tell them this one. You can go. You can suffer.
Yeah, in my head. I know what I'm saying.
But then Zn's going to be a plus 2 choice. Alright, good job on that.
Yeah, I didn't get it down, but I told you.
So Cn replaces Cu. Cu goes up by itself, so we got Cu plus Zn NO3. Zinc's a plus 2, nitrate's a minus 1. So when you guys see your charge sheet, you'll be able to figure out how many you need of each. Okay? Because when you look on your charge sheet, zinc's a plus 2. Right? Questions you guys have on. This is what I want you to do. This is question number 6. What I want you to do is I want you to list out these elements, and I'm not putting them in any particular order here. I want you to list these out, most active to least active. Okay, and then go ahead and put those symbols in here. So you'll have to put these over here, and this would be most active at the top and least active at the bottom. So go ahead and write those in your sheet according to so just go ahead and list in most active to least active. So this is number 6. Don't turn this over until after you have written yours in. Xander, up there, go ahead and write down which elements is most active to least active.
Oh, okay.
What's this?
Don't turn it over.
Turn it over.
Don't turn it over.
No, don't turn.
Quiz.
No, it's not.
Pass.
No. Okay. Now, through doing all of that, okay, I don't want you to write any of this down. I just want to talk a little bit about these solutions, and but don't write it down. Okay? If an ion in a solution reacts, okay, then that metal ion is lower activity. It's going to be replaced. So if you have a metal in the solution, okay, you have a metal in the solution, like this one, and we see a reactivity, then that is not as active as the one trying to replace it. So again, silver is not as active as copper, okay? Copper, so when we see a reaction, that element by itself can replace the element in the solution that's more reactive. Okay? So, going back to our statements, if a metal in a solution has no reaction, that metal has a higher activity. Okay? So when we go back here, see, magnesium's not replaced by copper. It's more active. Magnesium not replaced by zinc. It's more active. Here, zinc is more active than copper because it's kind of like a rating system. This is number 1. Nothing can beat number 1. And then you got your lowest level, number 4. Everything beats number 4. Okay? So when you guys put yours in here, you should have had magnesium at the top, right? Okay? And then the most obvious one was silver at the bottom.
Yeah.
Silver was replaced by everything. Okay? And then you'd have to pick out the next two. Well, zinc replaced copper, but copper didn't replace zinc. So zinc's number 2, and copper is 3rd. So if you got that right, good job of listing those out. If you would get this out and turn it over, find those 4 elements on your list and see if they're in that order. So find the 4 elements on the list and see if they're in that order. So just like we did on those 2 examples on the board, you're using that information from that activity table to see if something's going to happen or not. Okay. So you really don't want to build anything out of like pure magnesium or zinc because over a period of time, if it's outside, it's going to corrode. Okay. But you're not going to probably build anything out of gold, silver, or platinum. Why? Too expensive. So you got to find a happy medium to where it's relatively easy to get to, and it's not very active, and then that metal will probably be better use for things that are in the elements that might be outside. Did you guys see that Hard Rock Cafe that collapsed in New Orleans
I was watching
when they were building it? That's crazy.
What was that?
It happened over the weekend.
Hard Rock Cafe's a bad luck.
Well, they were just building it, so I don't know. During the process, something happened. It's a bad deal.
Anybody die?
I don't know if anybody died. I think they said they took some to the hospital, but I don't think anybody died.
Like 2 people.
Huh?
2 people.
2 people did?
Can you imagine sitting there eating, enjoying your day, and next thing you know, you're smushed?
the one thing I seen was it wasn't long.
We weren't supposed to do this side?
Not yet.
Oh.
We will.
Well, I did the wrong side.
Caleb, go down real quick. Do what you have to do.
On number 2, you want us to fill everything?
Now, on the back side, I'm going to do one for you on the back side. So if you're done with the front side, it won't take you very long. And I'm going to go through all the answers real quick. And you can see if you did them right or not.
Hold on, please. No, you can go
No, I'll give you time to do the front side, but the back side, I'm gonna do one example for you on the back.
Front side is
Don't
when
we
your
just do
name
the
is there.
backside, don't they? Up there?
Kind of, yep, we did. So if you wanna try, start doing some on the back side, you can. This would be, Xander, this would be kinda like what you do on
Yeah.
the back side.